Alright, concept C. The example is use the distance formula to find the areas of polygons. Determine which polygon with its given coordinates has the greatest area. So greatest means the largest. So I will keep that in mind. We're looking for the largest area. So a right triangle with its vertices at -4, -4, -1, 1. And that's A. This is B. C is at 4, -2. Okay. And it says AB is perpendicular to BC. That means that the right angle happens here. Okay, that's nice to know. Oh, that took too much. -4, -4. Okay. So now we just need to find the distances of each side length, and then we can 1/2 base times height. So I do not have to use, if that is the formula, area of the triangle is going to be equal to 1/2 the base times its height. So I only have to find AB and BC because there's its base and there's its height. I know this because AC is the hypotenuse. So if you were to, well, I'm looking at it all crooked, if you were to flip it and rotate it, you could see that this is the base and the height. So we need to find those two values. The reason I love graphs is because I can quickly count vertical and horizontal lengths. So the length of AB, here is our work. AB is going to be equal to the square root of the horizontal distance. So 1, 2, 3. So that is 3 squared plus the vertical distance, which is 1, 2, 3, 4, 5. 5 squared. And I'm going to just talk this one through. 3 squared is 9, 5 squared is 25, so 9 plus 25 is going to give us a value of 34. So AB is going to be the square root of 34. So there is one side length. The next side length we need is to find our height. So then here we go. Oh, and you might be saying, Mrs. Wood, you went down vertically, so shouldn't that be a -5? Yes, -5, that's why we love squares, and that's why we bring it in, is because -5 times -5 is still 25, so we still end up with the same result. And that's the beauty of having a square. An exponent is a 2. So BC is equal to the square root of, and let's count our horizontal distance, 1, 2, 3, 4, 5. So that is 5 squared plus our vertical distance, 1, 2, 3. It is going down, so it's -3 squared. And that's going to equal 5 squared is 25. Negative 3 squared is 9. So 25 plus 9 still results in the square root of 34. So we're going to come over here and type in the square root of 34. And I know, thinking back, I'm not sure if you guys have taken algebra, but the square root of 34 is the same thing as it being raised to the 1/2 exponent. I just wanted to bring up the calculator so we can double check that. It still came out to be 5.83. So let's see what it wants, it rounded to the nearest tenth. So let's round this 5.83. The 3 rounds the 8 to just 8 because it is below 5. So these are approximately both 5.8. Approximately 5.8. And so the area of our, I'm going to do this in my blue, the area of the triangle is going to equal 1/2 5.8, because that's our base, times 5.8. Okay, say I don't want to type in 1/2 as a fraction. Another equivalent form of 1/2 is 0.5. So 0.5 times 5.8 times 5.8, 16.82. The 2 is below a 5, so the 8 stays the same. 16.8. Alright, let's go type that in. 16.8. Check. There we go. And this one shows us without using the graph. They are using the coordinates for AB. And if you notice, -1 minus -4 reduces down to 3. They are using the horizontal distance, so the difference between your two x values, and they're just representing it algebraically. That's where the -1 minus -4 comes from, is it's the difference between your x coordinates, -1 and -4, and that's your horizontal distance. So they're just using some algebra. I like to draw it. I can see it graphically. It's the same. We're doing the same process. I'm just doing it using a graph. So find the area of the square, and it has our vertices at -1, +1. D is at 3, +4. E is at 6, 0. And F is at 2, -3. So this is D, that is B. Okay, so B, D, E, and F. And thank goodness I remember something about a square to cut back on some work, because none of these lie along a perfectly vertical or horizontal line. A square has the same side lengths, so I only have to find one side length, and the area of a square is side times side, or S squared. So pick a side length and find its length. I'm going to use BD. So BD is going to equal. So here's my triangle and the square root of the horizontal distance. So 1, 2, 3, 4. So 4 squared plus our vertical distance, which is 1, 2, 3. So 3 squared. That's going to equal the square root of 4 squared is 16. 3 squared is 9. So we're going to end up with 16 plus 9, which is 25. So we have the square root of 25, and I recognize that as the perfect square, which is 5. So we come back to our formula. That is our side length. So we have 5 squared. 5 times 5 is equal to 25. All right, so we have 25 square units. There we go. And it shows you using the coordinates.